seconds, 0.2 seconds, ये भी आपकी समझ में आ गया, और 1 second भी, मतलब you understand कि why did the 0.2 second, why the 5 hertz has been selected, why the 1 hertz has been selected, why the 1 second period has been selected, why the 0.2 second period has been selected by the code. Okay, yeah, this is very critical and very important. You got to understand that that's also the difference between the seismic philosophy of UBC and IBC. This is the big difference, because in UBC we focused primarily on peak ground acceleration. Peak ground acceleration is important for me, but what is structure is feeling, that is more important for me, right? What is I am feeling in the structure, that is more important for me. So it's spectral parameters, the spectral displacement, spectral velocity, spectral accelerations, these are all critical parameters. And when we develop this spectrum, then we have all these equations, we calculate from these equations, we calculate the base share. That's when you design your system, right? And now you understand everything. These slides, I'll email you guys also, because I put some notes into here, so that you can understand. Okay, the next topic is very critical, super critical, because that's the difference between UBC and IBC, and that's why we moved from UBC to IBC. That was the only reason. Not only reason, that was the very critical and basic and fundamental reason. What was the reason? Hazard versus risk. What is the hazard and what is the risk? UBC target just hazard. Risk target not only hazard. Risk target actually hazard plus the the failure. Matlab hazard plus the how the structure gonna respond. That's the risk. And this is the main difference. This is the main difference in the seismic philosophies, in the seismic philosophy of two different codes. That's why UBC is like we call it like outdated code. That's why no one designed it with UBC anymore, because it's because the results which we are getting for different structures is not the way the earthquake is acting on my structure. The way the earthquake forces are being experienced by my structure, and this is based on the peak ground acceleration, and this is an IBC based on the AC, based on now these days on its spectral, the actual feel by the structure, right? And then what's the meaning of this? Uniform hazard maximum considered earthquake 2475 year return period, 10% chance of the collapse. Here, risk targeted, okay, uniform risk. IBC uniform risk. What it says, okay, 10% chance of collapse, maximum considered earthquake sub R, risk targeted. You're gonna see it in the code. You will see exactly the same thing. Risk is targeted, okay? 1% chance of collapse and 50 years maximum risk. Assume fragility of the structure. See, this is very critical. UBC did not assume this, okay? IBC assumes it. Okay, seismic code. That's why here FISA puts a note. Seismic codes AC7 IBC use risk targeted ground motions instead of older hazard based maps. Make sense? Now, how you gonna remember it? Hazard is how strong is the shaking. See how strong is the shaking, and risk meaning how bad the consequences are. Okay, what does it mean? देखिए, this is like there I have 10 structures. Okay, let's say I have 4 structures, the 10 or 4 or 5, and then you excited all these structures. UBC is saying peak ground acceleration. Oh, design this one is the same way as this one, as this one, as this one. This is what UBC is saying, right? But IBC is saying no, because UBC is based on the hazard. UBC hazard meaning what is the magnitude and intensity of the shaking. IBC is saying no. The risk is because why? What? Why? Because IBC adopted the concept and philosophy of risk. How bad the consequences? Because it is considered assumed fragility of the structures, meaning how its structure will respond. That is more important for me. Okay, how big is the storm? It is important for me, but how the structure will respond, what will be the collapse, what will be the chances of collapse for my structure. And this is what IBC says. 1% chance of collapse in 50 years, maximum risk, right? But whether your house will be destroyed in the storm, yes or no. Hazard, how big is the storm? That's called uniform hazard. And risk targeted, meaning whether your house will be destroyed in the storm. So it depends on what? Then risk depends what is the structural integrity of your house. Make sense what I'm saying? Okay, these are two different philosophies. That's why everyone is stopped teaching or designing. Everyone is stopped designing the according to the UBC, because UBC is just the general guidelines, right? But IBC is more accurate, because IBC is giving telling you, okay, oh, your house gonna be destroyed, or there will be moderate damages, or there will be controlled damages. So that is the risk targeted risk. When we talk about the risk, meaning we are talking about how the structure will respond. And what is the response of the structure? Of course, it depends on the stiffness, it depends on the period, it depends on the damping, it depends on the mass, right? All those parameters, fundamental parameters come, all those fundamental parameters come back into the spectrum. Okay, oh wow, so this is actually which technique is better? Is the hazard technique is better, or the risk technique is better? Hazard is good because there is hazard, the storm is coming, the earthquake, the ground shaking is coming. But what will happen to the structure, that is more important for me. I'm concerned, okay, oh, what will be the intensity and the magnitude of the earthquake? Yes, I want to know. But I'm more interested, okay, I cannot stop that, but I want to know, okay, what should I do, okay, that there will be no collapse of my structure. That's called risk. That's it. Simple, simple. So same storm, pay attention, same storm, different houses. Oh, different risk. See this? That's why these are all different values in the code, right? You see the importance factor is different for different occupancies. You see resistance reduction factor R, which is called the response modification in the code, has the different values: 8, 5, 6, 3, 2. See, this is amazing. Why? What's happening? Why code is telling this? Because code is more concerned for the controlled collapse of your structure. Now makes sense. Okay, what is the meaning of uniform hazard and what is the meaning of uniform risk? If you run this and if you see it, so hazard, risk connects hazard and performance. Actually, just remember this. That's the best. Risk connects hazard and performance. Risk includes consideration of all hazard levels that influence the desired performance level, right? And see when we develop this graph, we see, okay, Memphis, this is the curve. Los Angeles, this San Francisco, New York. Oh, 2% probability in 50 years, certain period where I'm standing, right? So this graph shows that using the same hazard level, 2% in 50 years, does not give equal collapses risk across the regions. So AC adopted risk targeted spectral expressions to produce consistent risk nationwide. Make sense now? Now your concept is somehow getting close to it. Okay, okay, why the code committee moved from UBC to IBC? Because now we are targeting the risk, because we want to consider the performance of the structure also. We are not only dependent on the intensity of the earthquake. Yes, intensity of the earthquake is extremely important for me, of course. That's the acceleration, that's the ground acceleration, that's the peak ground acceleration I got to consider in my design. But that peak ground acceleration has anything to do, has nothing to do with my structural integrity, with my structural stiffness, mass, and the damping, or all other physical parameters, the shape of the structure, the response of the overall response of the structure. Of course, it is two interconnected parameters. Okay, whatever the ground acceleration I'm getting, peak ground acceleration I'm getting, and then how my structure is responding. That's called risk targeted. Guys, I cannot make it more simple, but I cannot make it simpler than this. And this is we already discussed. Okay, buildings have multiple modes of vibration: first mode, second mode, third mode, fourth mode, and then we need to combine all of them, and we get the one mode. This is what the concept of equivalent lateral force analysis in the code, because it captures the longest mode. It captures the mode which has the highest mass participation. What is the meaning of mass participation? The mass is responding to the external excitation to the peak of its ability. Okay, that's called the effective mass participation. Make sense? So we need to combine all the modes, but the if equilateral force analysis considers the one mode, and this is the beauty. This is where the related methods come to the picture, because the beauty of related method, because it's based on all the energy, the total energy of the system, and it captures the only one mode, that mode which is the dominant mode of the structure. Make sense? That's it. You can, Faiza, you can stop the video. And Samir, you can continue the video, because now we're gonna discuss like one by